Welcome to this episode of Elementary Math Minutes. This section of the second grade place value unit focuses on generating a number greater than or less than a given number and attributes of coins. For this section, you will need base 10 blocks, number lines, coins, and a number chart. Let's get started. In this section, students will build upon the previous lessons using base 10 blocks and number lines to generate numbers that are greater than or less than a given number. Let's look at this example. Mrs. Smith's class read a total of 847 minutes. I have 8 hundreds, 4 tens, 7 ones for 847 minutes. Mr. Brown's class read more total minutes than Mrs. Smith's class. How many minutes could have been read by Mr. Brown's class? I have 847 represented. I know that represents Mrs. Smith's class. So if I add base 10 blocks to my model, I'm going to create a number that is greater than 847. So let's say I add 3 tens. So instead of 847, I have 800, 4, 5, 6, 7 tens and 7 ones. So I have 877. Mrs. Smith's class read 847 minutes. Mr. Brown's class could have read 877 minutes because that is more than Mrs. Smith's class. So if I were representing that with a true comparison, it would look something like this. 847 is less than 877. Now, let's go back to our original model, 847. What if I take base 10 blocks away? What if I took a 100 away? What number would I have now? Well, I wouldn't have 847 anymore because I only have 7 100s, 4 tens, and 7 ones. So my number, 747. If my original number was 847 and now I have 747, my comparison would look like this. 847 is greater than 747. In this model, we want students to realize that if base 10 blocks are added to the model, a greater number is generated. When base 10 blocks are removed, a lesser number is generated. A number line can be used in the same scenario. Here I have an open number line where 472 is represented. If I move to the right of 472 on the number line, the numbers are greater than this given number. So if I move to the right, 485 would be greater than 472. If I move to the left of 472 on my number line, the numbers are less than this given number. So if I move to the left, 463 would be less than 472. Suppose students need to generate a number that is between two other numbers. Let's look at this scenario. Katie is thinking of a number. It is greater than 426 and less than 531. What could the number be? You'll see I have 426 modeled with base 10 blocks. We want students to understand that if we're adding base 10 blocks to our model, we're generating a number that's greater than 426. So I could add 2 tens to my number, and I would get a 446, 4 hundreds, 4 tens, 6 ones, still greater than 426 and less than 531. So that could be a number Katie is thinking of. I could also add a 100, 526, still greater than 426, still less than 531. So this could be the number Katie is thinking of. We'd want students to understand when we're adding base 10 blocks, we're generating a greater number. Now let's move to coins. This section focuses on determining the value of a collection of coins and using the cent symbol, $sign, and decimal point. In this section, students will be counting a collection of light coins only. Students will be introduced to counting a collection of mixed coins in the addition and subtraction unit. Introduce the $sign and the decimal point. Explain that the $sign is always written to the left of the value of the collection. The $sign tells the value of the dollars and the decimal point tells the value of the cents. Remember, the $sign is not used with the cent symbol. Let's represent the value of a nickel using the dollar sign and the decimal point. Now let's represent the value of a nickel using the cent symbol. Using a number chart, let's look at the relationship between the nickel and the dime. I can represent the value of a nickel by placing it on the 5 on my number chart, because I know a nickel is worth 5 cents. I can also represent the value of another nickel by placing it on the 10 on my number chart, because 2 nickels is 10 cents. I can represent the value of the dime by placing it on the 10 on my number chart. This shows me that 2 nickels have the same value as a dime. I can also show this with dimes. I know 1 dime is 10 cents. Another dime would be another 10 cents or 20 cents. Another dime would be 30 cents. Another dime would be 40 cents. And another dime would be 50 cents. So 5 dimes is 50 cents, which is the same as a half dollar. So 5 dimes are the same value as a half dollar. Thank you for tuning in to this episode of Elementary Math Minutes. We hope you'll find these videos helpful, and we look forward to you joining us next time. See you then.